Okay, so this is going to be the second video in our trigonometric substitution. And on the first one, I integrated this expression, which had constant minus function squared. I would now like to do an example where I have constant plus function squared. I'm not going to do this one because the trig integral ends up being a little tricky, but I'm going to do a modified version of that instead. So let's try, for example, integral x over square root of 4 plus 9x squared dx. Okay, so the identity that we're going to want to use here, since I have constant plus function squared, is going to be the a squared secant squared theta equals a squared plus a squared tangent squared theta. Now here, my a is 2. So what does this become? 4 secant squared theta is equal to 4 plus 4 tangent squared theta. And now I would like to make this portion under the square root look like the right-hand side of the identity, so I can replace it with the left-hand side and take the square root. So that said, 4 tangent squared theta, in the end, I need 4 tangent squared theta to be the same thing as 9x squared. So what should I change x to? Well, we'll just solve this for x, and that will tell us what substitution to make. I'd like x to equal 4/9, the square root of 4/9 times tangent, so that's going to be 2/3 tangent theta. And once we've decided what to call x, we'll take the derivative to get our expression for dx. So 2/3 secant squared theta d theta. And let's plug all this in here and see what happens. So I have x on the top. X is 2/3 tan theta. This dx technically is in the numerator of the fraction as well. So I've got another 2/3 secant squared d theta. And now on the bottom, we will have 4 plus 4 tangent squared. That was the point of the substitution. Now, how do we use the substitution? Well, we're going to replace 4 plus 4 tan squared with 4 secant squared and take the square root. So what do we end up with? Let's see, up top we've got 4/9 total tangent theta secant squared. On the bottom we've got the square root of 4 secant squared. That's 2 secant. And you can see that one of the copies of secant will cancel. That's going to leave us a total of 2/9 tangent theta secant theta d theta. Okay, now tangent theta times secant theta happens to be the derivative of secant, so that makes our lives a little easier here. Integration is not going to be difficult. 2/9 secant theta plus c. But now we do run into an issue. How am I going to get secant theta back in terms of x? So now you're going to have to go back and maybe review reference triangles from trigonometry, or hopefully what I show you now will be good enough. To figure out how to get secant theta back in terms of x, if you refer to the actual substitution equation, x equals 2/3 tangent theta, one can turn this into a right triangle involving the angle theta. So solving for tangent of theta, you get 3x over 2. Now how am I going to get secant theta back in terms of x? We're going to draw a right triangle for tangent, and recall that tangent is opposite over adjacent. So let's make a triangle here. So the opposite here, adjacent here, and this is the hypotenuse. So the easiest way to pull this off is to simply make the opposite side 3x, the adjacent side 2. Now, what we want is secant of theta, and secant of theta is the reciprocal of cosine. So if we can get cosine of theta, and I suspect that you learned the ratio for cosine of theta, we'll get secant by taking its reciprocal. So cosine is adjacent over hypotenuse. So for our triangle, we know what the adjacent side is 2. We don't know the hypotenuse, but we can get it with Pythagorean theorem. 2 squared plus 3x quantity squared is the hypotenuse squared. So if you solve for the hypotenuse using the Pythagorean theorem, you're going to get the square root of 4 plus 9x squared. By the way, it's no coincidence that that is the expression that we were substituting for in the original problem. Okay, so cosine of theta is adjacent over hypotenuse. That's 2 over the square root of 4 plus 9x squared, which means secant of theta is the reciprocal of that. Secant of theta is going to be the square root of 4 plus 9x squared over 2. Plus a constant, cancel the 2's. Okay. Now, one might note that this could actually have been done with a u substitution by letting u equal the denominator. I chose this one for the simplicity of the integral here. So now you have two different ways to solve this problem. So if you're interested, you can go ahead and check that this is correct by performing a u substitution. Try u equal 4 plus 9x squared.